Okay, in this video I'm going to continue the discussion of Boolean functions, and what I'll do here is first just write down what a Boolean function is. It is a function that maps the domain, which is bit strings of length n, to the range, which is a single bit, either a 0 or a 1. Okay, and what I want to do is I want to count the number of different Boolean functions that we can possibly make. So when we looked at functions, I showed you how you can specify a function in a tabular fashion, and I'm going to take the case of n equals 2, and I'm going to ask the question, how many possible Boolean functions for n equal 2. Okay, and I'm going to then make first of all, I'm going to figure out what does the domain look like. It's 0. The domain looks like 0, 1 squared, which is the Cartesian product of this set of 2 bits with itself. And in the Cartesian product, I gave the example in the last video. We're going to use a shorthand notation and write this as 0, 0, 0, 1, 1, 0, and 1, 1. Okay, and we can think of this function then as being a function of 2 different values, the first Boolean variable and the second Boolean variable, and I'm going to call them P and Q. Okay, and when I evaluate that function, it will yield a value which is either a 0 or a 1. Okay, so I'm going to go ahead and make a table of this function's values. So here's my function f. Here's my possible inputs, 0, 0, 0, 1, 1, 0, and 1, 1. There are 4 possible inputs to this function because the domain has 4 elements in it. And now I have a choice. For each of these, I can fill in the blank here with either a 0 or a 1. And I want to know how many ways there are to do this. Well, I can figure that out by kind of drawing a tree here for each step of the way. What I'm going to do is I'm going to suppose that I'm going to fill in the first one, the value for 0, 0 first, choose either a 0, 1, and then I'm going to move to choose a value for the entry 0, 1, and then choose an entry for the third and then the fourth. And so I get sort of a tree diagram here if I diagram this out. If I chose a 0 for the first one, I'll go to the left here. And then for the second one, I branch out again with either a 0 or a 1. For the third one, I branch out again for the 0 or the 1. And finally, for the fourth one, I have 0, 1 branches for each of those possibilities. And you can see that I'm doubling the number of possibilities at each step of the way. And the total number down here is 1, 2, 3, 4, 5, 6, 7, 8, 16. And basically what I'm doing here is I'm using the counting principle called the product rule. And we're going to see a lot of that this semester. Okay? Well, let's fix that up. Okay, this is the product rule. And basically, if I have a multi-step process, I can count the number of ways of completing that process. And my multi-step process was to fill in each of these 4 values for what the function could be. Remember, the domain of the function is these 4 different combinations of 0 and 1, and the range is either a single 0, is the set 0, 1. So each value in one of these little cubby holes is either a 0 or a 1. And so I'm going to calculate the number, capital N, of ways of filling in this chart up here by doing a 4-step process. And I'm going to multiply the numbers together. And I ask myself, for the first step, I have 2 possible choices, the 0 and the 1. And so I'm going to have a 2 here. And at every step I have 2 possible choices. And this gives me 2 to the 4th, or 16 ways of filling in this chart up here with 0s and 1s. Maybe I go 0, 1, 1, 0, for example. That's one way of filling it in. It's one of the 16 possible ways of filling it in. Okay? We're going to see many examples of this product rule this semester. This is just the first example. And now what I want to do is I can go to a new page here and just briefly show you that if I have a Boolean function with the case of a general n, okay, then my function is mapping 0, 1 to the nth to 0, 1. And the size of my domain, I showed you how to calculate that. The size of the domain now is the size of 0, 1 to the n. And the size of a Cartesian product is the product of the sizes of each of the sets. And this came out to be 2 to the n here. Okay? And so now, as I construct a table for this function f, okay, I'm going to have 2 to the n possible inputs, starting with n zeros and going all the way down to n ones. For example, if n were equal to 3, I'd have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, there are 2 to the 3rd, or 8 of those. In general, then, there are 2 to the n of these. And in general, then, if I want to specify a Boolean function for the general case n, I'm going to have a product principal that includes 2 to the n steps of choosing either a 0 or a 1 for the output. And I'm going to put a dot, dot, dot here, and I'm going to say times 2 again. And at every step of the way, I'm multiplying 2. And the number of them in this product is 2 to the n. And so this is 2 raised to the 2 to the n power. Okay? And so, for example, when little n is 3, I have 2. Oh, it stopped. Oh, it came back again. Okay? When little n is 3, for the case little n is 3, I have 2 to the 2 to the 3rd, 2 to the 8th, or 256 possible Boolean functions. Okay, I'll stop here.